here is a really fast video just to make sure you're comfortable with this one type of problem on Delta Math, and that way you can listen to me and not watch their help video. So you're going to have a section in Delta Math where it asks you to determine based on a picture, which definite integral is the smallest of all of them, or which definite integral is the biggest of all of them. And it will not be geometric, and it will not be something that we actually are given the areas, but we can make an approximation based on location. So I'm going to mark this up a little bit just to make this one make more sense and kind of talk you through what's happening here. So your first choice is the integral from 0 to 3. So your integral from 0 to 3 is this stuff. And what I know about that is I know it's going to be a positive answer. My next one is the negative 7 to 3. So negative 7 to 3 is going to include this. It's also going to include this. So you're going to have two positive areas, but you're also going to have a pretty big negative area. So while that answer, I'm not totally sure if it's positive or negative, it's going to be smaller than 0 to 3 because you definitely have more green stuff from that negative 4 to 0 than you do the extra yellow stuff from negative 7 to negative 4. So this one's going to be a little bit smaller. Negative 7 to negative 4 is definitely positive the whole time. I want to write that in pen because I don't want to write it in yellow either, because it's always positive. 0 to 8. So 0 to 8, notice that from 0 to 8, it has that yellow region, but it also has a much bigger green region, which is going to tell me that that answer for sure is going to be negative. And it should be the smallest one we've got because we know negative 7 to 3 did have some positive stuff that's going to kind of go into the mix. So we are going to choose that one. And here's what it'll do. I'm not going to estimate areas. I know it talks about estimating, and you could like count the squares. If you're really struggling to figure out the area, you could play like, let's count the squares. I think it's easier to just kind of look at it and talk about positive or negative. They spent a little more time than I would. I'll show you one more, and then we'll be done with this. This one wants to know which integral would be greater than the other three. So we are looking at 5 to 8. Sorry, let me mark this up a little bit. So 5 to 8 is this piece. So that one's definitely positive because it's only above. Then we are looking at 1 to 5. So 1 to 5 is going to have more stuff that's negative and just a little bit of positive. So that one's definitely going to be smaller because it has so much negative there. So far, 5 to 8 is the biggest. Then negative 5 to 5. So negative 5 to 5 has all of this, but then all this negative stuff. And then finally 1 to 8. 1 to 8 has more negative than positive. All right, so let's see. I'm trying to figure out the difference between negative 5 to 5. So negative 5 to 5, maybe I will start counting squares. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, somewhere around 20 is my guess. Then if I do which one was it? 5 to 8. Oh, that's much smaller. Let's see. So 1 to 5, we have 1, 2, 3, 4, 5, 6, 7, 8. Now, I still think from negative 5 to 5 is the biggest. If I'm wrong, I'll try again. There we go. And they did some, oh, my approximation was pretty good. I said it was around 20. It says it was 19. So that's how we do that section. You're going to use that kind of general approximation, and it's going to ask you either which integral is the biggest or which integral is the smallest. Pretty quick.